Hello, my name is Marcus, and I am learning Rust by going through the Project Euler problems. Today I'm on problem number 5. So we're trying to find the smallest multiple. So looking through the numbers 1 through 10, what is the smallest number that can be easily divided by all those numbers? So the problem then is, the example gives us 2520, so then for 1 through 20 is our goal. So let's dive in. I've already started, I've queued up my thing. And so now I need to look at how to solve it. So I need to know the divisors. So if I get all the smallest prime numbers, because you have to multiply each prime by each other, that will go into the smallest number. And then we need to make sure that we have enough extras. So the extras are kind of like here, 4, 4 is 2 2s. We'll need 2 2s in the number, so that can divide it. This is 3, 2. 8 would be like that. And so each of these, what we'll do is take our primes 2, 3, 5, 7. And we can remove that from this list because they're down there. And then here we need another 2 for the 4. The 6, there's a 3, 2 below, so we don't need that. The 8, we need 3 2s to be able to make an 8 divisible. And then for the 9, we need 2 3s. And for the 10, we need a 5 and a 2. So that, whoops, that should do it there. Let's replace space with that. Didn't work. Like that. Yeah, I'll just copy and do it. So this should be our answer, right? Print line. Like that. And if we run that, we get 2520. So that is our setup. So now we need to think, how did we do that? So we had it like this. So we're going to need prime numbers, and then we'll get like kind of prime factors of it. Something along those lines. So let's start off and let's get all of our primes. Let's start off with our number. And so let's get our primes. Now, we already did a find primes one, so let's use that function. So that was in problem number 3. Here we go, our find primes. So this one for, let's copy that. And what we can do, instead of just copying it into here, let's actually learn something and do it kind of properly. We will learn, let's make a file so we can put that somewhere. There we go, let's do that. Let's learn how to do a proper library for Rust. All right, so Rust lang include local library. How to include a module from another file. Perfect. All right, ignore the question. We want to do this. Hello rs mod hello. I don't want nested modules, I just want one. That looks relatively simple, and I don't put anything there. That looks about as easy as we can do it. And basically what we have is more or less it, right? Yeah, let's try it. So we save this, we come here, we did mod primes. And then I think we do have to prefix it, right? Yeah, so we prefix it with that mod, which is kind of like how you do other includes for instead of a use, you use that as a prefix. Let's print out and see what we got. And let's run it. All right, find primes is a private function. Okay, so we probably have to declare that as public. Sort. So declare that as public. Run 2, 3, 5. That is not the right answer we expected. We expected 357. So let's write a test over here. And function test find primes. And for your tests, they don't have to equal the function name. I always do it, but it's a good idea so you know which one you're testing. So find primes 10, we should get 2, 3, 5, 7. Let's run that. Test fails. All right, we're getting 2, 3, 5. Oh, okay. So for the previous one, so this one, find primes less than none. The previous one, we were using a factor because we just only needed to, we were finding primes that could be a factor of a number. This one, we want to find all the primes that are less than that number. So we can do that. There's also an optimization here that I realized after the fact, is we can count by 2s. Because we don't have to check even numbers. They will never be prime. Let's check that. Let's run it. Not found on this scope. Oh, max. Because it's not max. It's called num. Test. All right. So our primes are working. Let's go back to our other program. All right. And we run this. There we go. 2, 3, 5, 7. Now what we want to do is we got primes. We want to get the prime factor. So what we want to do is we want to call a function that calls because we know all these will be part of our number, but we want to get all these duplicates. So we want to call a function. If we pass in 8, it will give us back 2, 2, 2, like that. Let's call that a prime factor. And when I think we can probably put that in our primes also. Why not? We got a module. We're going to use it. Primes, find prime factors. And we'll pass in a number. Let's pass in 8 for now. That's fine. We'll just do that. All right, so public function find prime factors. It's going to pass in a number, and we're going to return a vector. Let's define this because I don't have prime factors as the actual name. Find prime factors for num with duplicates. I don't know if that's really the name of what these are. 8 will give 2, 2, 2. Because 2 would be the prime factor of 8. I don't know if 2, 2, 2, if there's actually duplicates in that definition. Factors equal, let's be a vector, U64, new return factors. All right, and let's write our test. Test find prime factors. Assert equals, we're going to pass in a number, find prime factors, and we want that to equal an array or a vector, like that. That should equal, look like that. We can do a couple others. Let's do 9 should give us 3, 3, 6, we give us 2, 3, 12 will give us 2 times 2 times that. 2 times 2 times 3 is 12. All right, so we do that. We compile, we're failing, that's fine. So to find a prime factor, so what we need is we need our primes for that number, right? So let's get our primes for our number. And we want to see how many times that primes will go into it. All right, so we want to reduce this 8 by a prime each time. So like while, let's loop over our primes. And so then while we loop, we want, let's have a temporary number that will be mutable. That will be our number. And then while this number is modulo the p, it's divisible. Let's push that to our factors. Let's reduce that number by p. And then we return the factors. So we're going to push. So factors are starting empty. Our number is 8. 8's divisible by 2. We're starting with 8. We reduce 8 by 2. Push it on. 4, 2, 2. I think that will work. Let's test it. I don't think I saved. I need to have my save command run before that. All right, pf at this intentional prefix with underscore. That's fine. Mutable factors. All right, I need to make this mutable, and that should be fine. Test failed. 842. 842. Oh, I'm probably pushing on the number, not the prime. Let's see if that's it. Hey, our test pass. All right, so our prime factors are working. So that means we can call in our main, we can call this function and we'll get that. So let's loop through all of our numbers into max. We keep our factors. So then the last thing, I think what we want to do, we want this to be an x, is that we want to do, we want to merge the two. We're doing this mental merging. So if we had already had 2, 3, 5, 7, these are our primes already in, we would only take one of these things and merge it in. So we want to, it's kind of like a vector intersection. So we pass in our vector, we pass in our new prime factors, and then we want that to equal this. So we want, if we pass these two in like this, it would return something like 2 more of these. All right, so we can write a test for that. So we want a function called vector intersect. It's going to accept a vector A, be 64, and we'll have a vector B, 64, and you're going to return a vector, use 64. Let's return A. We'll just mutate that. And what we'll do, we'll loop through every element in A. If that element is in B, let's remove it from B. This, like this. Let's get our logic right, and then we can fix things up, right? Right. Reach out up, and I want to append whatever is left over. We want to, left over in B, we want to append to A, then we return it and we'll get all. So now if we get this array passed in as A, 2, 3, 5, 7, we loop through each one, we remove one of those items, one of those 2's from B, then we do it again, then we do it again, and we'll be good. All right, let's try and run this and see what happens. Oh, we didn't write our test. So our test would be test function intersect. And here, what we want to do is intersect vector 2, 3, 5, 7, and 2, 2, 2. And we expect 2, 3, 5, 7, 2, 2. We probably can do some more tests, but I don't know how many tests we actually need to test that out. My auto formatting looks funky, but so be it. You do your thing. All right, let's run that test. Element, okay, I got some bar items. It doesn't like using remove item has been unstable. No, that's been deprecated. All right, and I should do some other things here. All right, so let's get, I think this is no longer working, so we want to, okay, so this remove item is been deprecated. So let's take a look and see. Rest, remove item from vector. Remove element from vector. All right. Iter position, that works. Let's try that. So this is a little more functional programming, which is fine. What we want to do is get the index. We're going to go make an iterator over that. We want to get the position. That's going to give us an element. And we want to check if that equals our element. I think it's going to be like that. I think we have to do dereferencing and a whole bunch of weirdness. But this could be empty. So let's say not found. So expect I didn't unwrap before. That would bail if it's not found. This says like it's allowed to be not empty, and it won't break. It should still be. It's going to through each position, so it may not have each element because it could be like 2, 2, 2, 3 or something else. And it's fine if that's empty. So then remove is actually on the index, not on the value. I think that should work. I think I still have to do a borrow there. I think this B, so the way append works also requires B to be mutable. So you have to do the syntax like that. If I don't do it, it'll tell me what's wrong. So it's saying the mutable B. So append, if you look at the docs for Rust docs, Rust vector, that's fine. Should just leave this page open. I'm doing all this stuff. And for append, it changes. So there's vector 1, append vector 2. It needs to be immutable because at the end, after you call this function, 2 is then empty because it's all been appended to 1. I think it's a bad design decision, but whatever. It is what it is. So just call this with this. There should be just another function to like join it without having everything mutated. All right, I think that might do it. Let's run that. Let factors. First assignment of factors. Oh, I think factors have to be mutable too. All right. Oh, that was in my actual program too. I want to run the test on primes. All right, my tests are working for my primes. Oh, it runs both tests. That's interesting. It's not just for this file. It's also running the test. I just noticed it's running the test for vector. So it runs it for the whole project, which I guess makes sense because my commands are actually out here. It's running like cargo test. So that's for the whole project. All right, I think we are just about there, right? We have our factors. We have that. Let's just find our product, right? Let product equals 1 because as we multiply things, 1 times 1 is 1. Let's grab each factor that we found and let's multiply them. And then this should be our lovely answer. QED and the product. All right, for 10, let's run it. And we ran a test. Let's run the build. 25, 20. There's our factors. We are looking good. We're actually printing this up here, which we don't need. We can actually print this down here. It'll give us all of our factors that we found. So let's run that. Oh, I borrowed it after I moved it, so I'd have to do this. All right, so there's all the factors I found. That makes 25, 20. And then you just change it to, you change that to 20, but I'll do it for 15 to show that it works. Run it, and there we go. And that is Euler number 5, and we learned a little bit about modules. I think we'll break this out into its own actual library, so then we can use it from a bunch of stuff. That'd be quite useful. All right, hopefully that was useful. Thanks so much. Cheers.